Question 1, we need to find the first four terms in ascending powers of x of 2 minus x over 4 to the power of 10. We need to give each term in its simplest form, so it's just the binomial expansion. We've got 2 minus x over 4 to the power of 10. So we start with the full power loaded onto 2, plus 10 choose 1, 2 to the power of 9 times minus x over 4, plus 10 choose 2, 2 to the 8 minus x over 4 squared, plus 10 choose 3, 2 to the power of 7 minus x over 4 cubed, plus dot dot dot. Notice that as the power on 2 decreases by 1, the power on negative x over 4 increases by 1. Also notice that I always put a plus in between the terms, and I use brackets here to avoid any mistakes with the negative sign. I put everything on the calculator. I get 1024 minus 1280x plus 720x squared minus 240x cubed. These are the first four terms, so from a constant up to and including the x cubed term. Part B, it says hence find the constant term in the series expansion of this expression here. So we've got 3 minus 1 over x squared times 2 minus x over 4 to the power of 10. So this is 9 minus 6 over x plus 1 over x squared times the expansion. We just found the first few terms, 1024 minus 1280x plus 720x squared minus 240x cubed plus dot dot dot. Well, the constant term can arise out of a constant times a constant, the over x times x and the over x squared times x squared terms. So this is the only thing we need to consider. So this is 9 times 1024 plus negative 6 over x times minus 1280x plus 1 over x squared times 720x squared, which is giving me 9216 plus 7680 plus 720 plus dot dot dot, which is 17,616 plus dot dot dot, and therefore we can conclude that the constant term is simply 17,716. In question 2, we need to complete the table here, giving the values of y to 3 decimal places. So we only need to use the calculator for x is 0 and 0.5. This gives values of 0.577 and 0.686, and then use the trapezium rule with all the values of y to approximate this integral here. So the trapezium rule is given in the formula booklet. We know that this will be approximately a half times the height of the trapezia, which is always the difference between two consecutive values of x in the table. So that's going to be 0.25 in our case. And then it's the first and the last y values taken into account once, and all intermediate y values twice. So 2 times 0.577 plus 0.653 plus 0.686, and this is giving an answer of 0.624. In question 3, we've got f of x given here, and we are told that when it's divided by x plus 4, the remainder is minus 108. This means that f of negative 4 is minus 108. So we will be substituting x with the value of negative 4, which means that minus 108 is a times negative 4 cubed minus negative 4 squared plus b times negative 4 plus 4. So minus 108 is minus 64a minus 16 minus 4b plus 4, leading to 64a plus 4b is equal to 96. Divide everything by 4, you get 16. A plus B is 24 as required. Given also that 2x minus 1 is a factor of f of x, so if 2x minus 1 is a factor, that means that f over half is 0. So we will use this fact to extract another equation, another relationship between a and b. So we get that 0 is a times a half cubed minus a half squared plus b times a half plus 4. And therefore 0 is a over 8 minus a quarter plus b over 2 plus 4. I will multiply everything by 8 to get rid of the fractions, the denominators of 8. So 0 is a minus 2 plus 4b plus 32, which means we get that minus 30 minus 4b is a. We're now facing a system of simultaneous equations in a and b. So we will proceed by substitution in solving this. We get that 16 times a, which is minus 30 minus 4b, plus b is 24. So minus 480 minus 64b plus b is 24, which means that minus 504 is equal to 63b. And therefore we get that b is negative 8, and therefore a is negative 30 minus 4 times b, which is equal to 2. So the value of a is 2 and the value of b is negative 8. In C, we need to find f dash of x, so we will differentiate. We know that f of x is now 2x cubed minus x squared minus 8x plus 4. So upon differentiation, we get the power down and deduct 1 from the power to get 6x squared minus 2x minus 8. And for part D, we need to find the exact coordinates of the stationary points. Now, stationary points means that the y dx is 0. So we will set 6x squared minus 2x minus 8 to be 0. I will start by dividing everything by 2 to get 3x squared minus x minus 4 is 0. This factorizes into 3x minus 4x plus 1, which means we've got roots at x is 4 over 3 and x is negative 1. We also need to find the y values for each of these x values. So for x is 4 over 3, I will substitute this into the equation for f of x, and I get that y is minus 100 over 27. And for x is negative 1, substituting again in f of x, we get that y is 9. And therefore the coordinates are 4 over 3, minus 100 over 27, and negative 1, 9. 2 turning points. In question 4, it's the points P and Q here, with PQ being a diameter of the circle, and we need to find the coordinates and the radius of C. So I will actually start by finding the coordinates of the center. We know that since PQ is a diameter, the midpoint of P and Q will be the center of the circle. So minus 11 plus negative 3 over 2 is equal to negative 7, and 6 plus 12 over 2 is equal to 9, and therefore the center of the circle is minus 7,9. And for the radius, I will simply find the distance between the center and one of the 2 points. So I could say that the radius will be 9 minus 6 squared plus negative 7 minus negative 11 squared and all square root. So I took the center and one of the 2 points. This is giving me an answer of 5. So we're looking at a circle centered at negative 7, 9 with a radius of 5. Now for the equation of C, we know that in general a circle which is centered at alpha beta with a radius of r has this equation here, x minus alpha squared plus y minus beta squared is r squared if the center is alpha beta and the radius is r. So in our case, we've got that x plus 7 squared plus y minus 9 squared is 5 squared. And then in part C, we need to find an equation of the tangent to C at the point Q, giving our answer in the form ax plus by plus c is 0 with a, b, c being integers to be found. It makes sense here to draw a quick sketch. Doesn't have to be accurate or anything. We've got a circle, it's centered at negative 7, 9. We've got the point P, the point Q, maybe somewhere here, and we've got the tangent at Q. And we know that Q has coordinates negative 3, 12, and we have to find the equation of the tangent, the equation of this straight line. I will actually start by considering the gradient of the radius, and I will explore the fact that this angle here is a right angle. So the gradient of the radius is simply y2 minus y1 over x2 minus x1. So it's 12 minus 9 over negative 3 minus negative 7, which is giving an answer of 3 over 4. And therefore, the gradient of the tangent will simply be minus 4 over 3. Remember, we are flipping and changing the sign. I will then be using y minus y1 is mx minus x1. So y minus 12 is minus 4 over 3, x minus minus 3. I will cross multiply to get 3y minus 36 is minus 4x minus 12. And I need to collect everything on one side to match the form I was asked to give my answer to. So 3y plus 4x minus 24 is 0. In question 5, Ben is saving for the deposit for a house over a period of 60 months. He starts off by saving £100 in the first month, and he increases this amount by £5 each month so that the amounts form an arithmetic sequence. We are asked to find the amount that Ben saves in the 40th month. So I will simply create a quick table here. It's the month and the amount of money that Ben is saving. In the first month, it's £100. The second month, it's 100 plus 5. Then in the third month, we go to 100 plus 2 times 5. And I can easily spot a pattern here. So that in the 40th month, it's going to be 100 plus 39 times 5. I notice that the multiplier here is always 1 less than the month, and this gives an amount of £295. Then in B, we need to find the total amount that Ben saves over the 60-month period. So we're looking for the sum of this arithmetic sequence. We've got the first term being 100, the common difference being 5, and we're looking at the sum of 60 terms. So we know that S60 will be 60 over 2 times A, which is 100, plus N minus 1D. And this is giving an answer of £14,850. Now we've got Lina, who's also saving for a deposit for a house in a different way. She starts off by saving 600 in the first month, and this amount drops by £10 each month. So we've got the formation of a second arithmetic sequence, and given that after n months she has saved exactly 18,200, we need to show that this equation in n holds true. So what we're looking at here is an arithmetic sum again, with first term being 600. The common difference is negative 10 because the amounts drop by 10. and we've got n terms. So Sn will be n over 2, 2a plus n minus 1d. So we have been told that this is 18,200. I will start by cross multiplying with the 2 here. So I get n times 1200 minus 10n plus 10 is 36,400. So n brackets 1210 minus 10n is 36400. I will further expand this into 1210n minus 10n squared is 36,400. I'll divide everything by 10, so 121n minus n squared is 3,640, which leads to n squared minus 121n plus 3,640 is 0, which is exactly the result we were trying to obtain. And then D, we need to solve the equation we just found. Now this factorizes into n minus 65, n minus 56. Alternatively, you could have used the quadratic formula. So this leads to the conclusion that n is 65 or n is 56. And then in part D, we need to state with a reason which of the solutions is not a sensible value for n. So I need to state the non-sensible value and then explain why this is so. So obviously we go for n is 65 is not a sensible solution. And this is because we would have saved the amount of money by the 56th month. So n is 65 is not a sensible solution as the amount will be saved earlier. After 56 months. In question 6, we've got two curves, C1 and C2. These are the definitions of the curves. And the point A has coordinates 1, 4. And using algebra and showing all steps of the working, we need to find the coordinates of B, which is the other point of intersection. Obviously, for points of intersection, we need to set the two equations to be equal. So that will be my starting point. So I have that x cubed minus 6x plus 9 is equal to negative 2x squared plus 7x minus 1. I'll collect everything on the left-hand side to give me x cubed plus 2x squared minus 13x plus 10 is 0. We are looking at a cubic here, but we already know that one of the solutions is at x is 1 because we have been given the coordinates of A. So I'm just gonna say here that we know that x1, x is 1 is a solution, hence x minus 1 is a factor, and this will allow me to start the process of long division in order to simplify the cubic. So I've got x cubed plus 2x squared minus 13x plus 10 to be divided by x minus 1. Remember, with long division, I'm always trying to kill off the highest order term. So I will multiply this by x squared to give me x cubed minus x squared. This leads to 3x squared minus 13x plus 10. Then it's a plus 3x to give me 3x squared minus 3x. Again, I subtract and I get minus 10x plus 10. So minus 10 here to give me minus 10x plus 10. And as expected, I get a remainder of 0. So now I have to solve x minus 1, brackets x squared plus 3x minus 10 is 0. So I will further factorize this into x minus 1, x plus 5, x minus 2, which gives me 3 solutions. X is 1, or X is -5, or X is 2. We already know that X is 1 is point A. We know that the two curves are only defined for positive values, so we cannot have X is -5, so I will reject this. So it means that the X value of point B is 2. The only thing remaining is to find the Y value, so I will substitute 2 cubed minus 6 times 2 plus 9, which gives an answer of 5, and therefore point B has coordinates 2, 5. In part B, we need to find the finite region R using algebraic integration. So we already know that this X value here is 1 and this one here is 2. These are actually the limits of the integration, and we always do the integral of the curve above, which in this case it's C2, minus the curve below, which is C1. So the area R would be the integral from 1 to 2. The curve above is minus 2x squared plus 7x minus 1. And the curve below is x cubed minus 6x plus 9 with respect to x. Notice the use of the brackets here to avoid any mistakes with the negative sign. The first thing to do is expand and simplify whatever's in the integral here. So it's the integral from 1 to 2 of minus x cubed minus 2x squared plus 13x minus 10 dx. Remember that with integration we increase the power by 1 dividing by the new power. So it's minus x to the 4 over 4 minus 2x cubed over 3 plus 13x squared over 2 minus 10x from 1 to 2. I will substitute the upper limit. So minus 2 to the power of 4 over 4 minus 2 times 2 cubed over 3 plus 13 times 2 squared over 2 minus 10 times 2. So this is the upper limit substituted minus the lower limit substituted, minus 1 to the 4 over 4 minus 2 times 1 cubed over 3 plus 13 times 1 squared over 2 minus 10 times 1, and this is giving minus 10 over 3 minus negative 53 over 12. So all in all, this is 13 over 12 squared units. In question 7, we need to show that tan theta plus 1 over tan theta is 1 over sine theta cos theta. This is an identity we need to prove to be true. So we start from the left-hand side. It's tan theta plus 1 over tan theta. We know that tan theta is sine theta over cos theta, and therefore the 1 over tan theta can be written as cos theta over sine theta. We can combine these two fractions together over a common denominator of sine theta cos theta by multiplying the first one by sine theta to give us sine squared theta, and the second one by cos theta to give us cos squared theta. We know that sine squared theta plus cos squared theta is 1. So this is 1 over sine theta cos theta, which is the right hand side as required. Now in the II part, we need to solve for x between 0 and 90. So we're in degree mode. The equation 3 cos squared 2x plus 10 is 1. We need to give our answers to one decimal place. So we will actually start by saying that if 3 cos squared of 2x plus 10 is 1, this means that the cos of 2x plus 10 is plus minus 1 over 3 square root. So we've got cos of 2x plus 10 is the square root of 1 over 3, or cos of 2x plus 10 is minus the square root of 1 over 3. These will give me two principal values. So The first principal value is 54.7356, which means that 2x plus 10 is plus minus 54.7356 plus 360k. I will actually split this into two, one for the positive, one for the negative. So we've got 2x plus 10 is 54.7356 plus 360k, which means that 2x is 44.7356 plus 360k, and I'll divide everything by 2 to get x is 22.4 plus 180k, and the alternative is that 2x plus 10 is negative 54.7356 plus 360k, which means I can deduct 10 to get minus 64.7356 plus 360k, and therefore x is negative 32.4 plus 180k. And similarly, I can turn on to this equation here. I get a principal value of 125.2644 and proceed in a similar manner. 2x plus 10 is plus minus 125.2644 plus 360k. So 1 for the plus. So 2x plus 10 is 125.2644 plus 360k, which means that 2x is 115.2644 plus 360k, and therefore x is 57.6 plus 180k. And for the negative, we would say that 2x plus 10 is minus 125.2644 plus 360k. I will deduct 10 to get minus 135.2644 plus 360k. And then if I divide by 2, I get x is minus 67.6 plus 180k. And therefore, out of these four equations, I need to generate all solutions between 0 and 90, bearing in mind that k is an integer. It could be negative, it could be 0, it could be positive. If you substitute in values for k, you get x is 22.4 and 57.6. These are the only solutions between 0 and 90. In question 8, we've got a geometric series with the first term a and a common ratio of r, and we need to prove the summation formula. So I will actually start by writing out that Sn means u1 plus u2 plus u3 plus ... plus un. We know that the first term is a, the second term is ar, it's then ar squared up to and including ar to the n minus 1. I will now multiply everything by r, and I get rsn is ar plus ar squared plus ar cubed plus ... plus ar to the n. And I could now deduct one from the other, and I will see lots of simplifications. These will go away, and I'm left with the first term here and the last term over here. So I could say that Sn minus Rsn is a minus ar to the n. I will factor out the Sn. Sn 1 minus r is a brackets 1 minus r to the n, which means that Sn is a 1 minus r to the n over 1 minus r as required. And then we're being told that the second term of a geometric series is minus 320, and the fifth term is 512 over 25, and we need to find the value of the common ratio. I will actually start by writing out that the second term is minus 320 which is AR, and the fifth term is 512 over 25, which is AR to the 4, and U5 over U2 is equal to 512 over 25 over minus 320, which is AR to the 4 over AR, and therefore we get that minus 8 over 125 is R cubed, and therefore R is the third root of minus 8 over 125, which is minus 2 over 5. Now in C, it says, hence find the sum of the first 13 terms, giving the answer to 2 decimal places. We need to find A, so I could say that the minus 320 is A times minus 2 over 5, which gives A to be 800, and therefore S13 is 800 brackets 1 minus R to the n, which is 13, over 1 minus R, and this gives an answer of 571.43. Question 9, first part, for 4 marks, we need to find the exact value of x for which this logarithmic equation holds true. So we have log of x plus 5 base 3 minus 4 is log of 2x minus 1 base 3. I will collect the logarithms on one side to combine them into a single logarithm. So log of x plus 5 minus log of 2x minus 1 all base 3 is equal to 4, which means that log of x plus 5 over 2x minus 1 base 3 is equal to 4, and therefore x plus 5 over 2x minus 1 is 3 to the power of 4, which is 81. I will now cross multiply to get x plus 5 is 2x times 81 is 162x minus 81, and therefore we get 86 is 161x, which means that x is 86 over 161. In II, we have this equation here, and we need to show that it leads to 0.75 to the y is 2. So we will start with the equation that was given to us. We've got 3 to the y plus 3 times 2 to the 1 minus 2y is equal to 108. So 3 to the y times 3 to the 3 times 2 to the 1 times 2 to the minus 2y is 108. Now, this means that 3 to the y times 27 times 2 times 2 to the minus 2 to the y is 108. So 3 to the y times 54 times a quarter to the y is 108. Now, 3 to the y times a quarter to the y, we've got a product to the same index, to the same power, so I can multiply the bases together. It's 3/4 to the y is equal to 108 over 54, which is 2, and therefore we obtain that 0.75 to the y is 2 as required. Then for B, we need to find the value of y, giving the answer to 3 decimal places. So we've got 0.75 to the y is equal to 2, which means that I can take logs of both sides. Log of 0.75 to the y is log 2. So y log of 0.75 is log of 2, which means that y is log 2 over log of 0.75, and this gives an answer for y of minus 2.409.